on Microsoft Teams. I'm going to show you how to access it. If somebody can start the recording so that, okay, thank you. To access that class notebook, what you're supposed to do is you're supposed to go to this theme of Stat 319 section 2. And at the top, you will see this class notebook. When you click on this class notebook at the top, you should be able to see in a few seconds the OneNote class notebook for this course that I'm using. And specifically, I'm using this content library section to store all the contents. So if you click these 3 books on the top left corner of your class notebook, you'll be able to see some of the folders here. For me, I can see all the students. For you, you will be able to see only your name. You'll see the collaboration space. In this space, what you post, everyone can see, everyone can edit. So if you guys want to collaborate with each other, you can use this space to post things, to comment, to collaborate with each other. This content library, this is what I'm using. What I post here can be seen by everyone, but it cannot be edited by anyone. Now in this content library, you will be only able to see a single page, which is probability chapter. As we keep going in the course, you will see more pages here. And then you will be able to see your name. For example, Abdul Aziz, when you will open your folder, you'll be able to see a single section here, handouts. This will be an empty single section. So whatever you post here, only I will be able to see. So if you want to share anything with me in private, you can post it in your folder and send me an email that I want you to see this I posted in my folder. You can create new pages inside your folder. You can create new sections inside your folder. This notebook is also accessible through OneNote. If you go to OneNote and you click on more notebooks here. Is my screen visible?
Yes.
Yes.
If you go to OneNote and you click on notebooks and you click on more notebooks, here you'll be able to see all the notebooks, and you should be able to see one of them named, I think it's already there, so you will not see it there. In the top, you will be able to see somewhere 203 Stat 319-02 notebook. I have already transferred it to recently used one, so I don't see it here. For me, I see it here in this list. So for you, first time what you have to do is click on more notebooks. And when you click on more notebooks, you should be able to see the notebook for 319 section 2 somewhere at the top. Somewhere close to the top. So this is the notebook we are going to use and store everything in this one. Again, if you want to collaborate with each other, you can use this collaboration space, create new pages here, and you can post whatever you want your colleagues to see. And if you want to collaborate with me in private, you can use the folder by your name and let me know through email that I have posted something in my folder. Go and check and comment on it. Now, when you come and paste something in the folder, it is always recommended that you paste in printout format. For example, here, I want to start a new example. I have option to insert as a file, insert as a printout, and insert as a picture. So if there is a PDF, I would prefer to see it as a printout, not as a file. Because if you attach as a file, I will have to download and then open. As a printout, I'll be able to see it directly here and comment on it. So let us start with our lecture. In the previous class, we were talking about some of the counting techniques. We said that when we have a single picking, the counting is very easy. It can be done manually, and we did it manually. But when the number of pickings is more than one, we noticed that counting manually, it took a lot of time. Even for 2 pickings, it took a lot of time, and we discussed if there are 3 or 4 or 5 or 7 pickings, it will take a very huge amount of time. The number of outcomes will be in thousands, and it's almost impossible to sit down and make 1,000+ outcomes manually. So we said that there are counting techniques that can be used to find the numerator and denominator of probability without going into the sample space manually. Those counting techniques are multiplication rule for the case where you are picking with replacement, permutation case where you are picking without replacement but with order, and combination case where you are picking without replacement and the order is not important. And then we said that without replacement and without order is the default case. So if there is no information, no indication given in the question, whether you are picking with or without replacement, whether the order is important or unimportant, you'll go with the default case. We did an example and we discussed several aspects of picking with, without replacement. At some points, we also discussed the use of complement rule. Muhammad Ali.
Doctor, this note is not for our section.
Come again, please.
This note is not for our section.
This note is not?
For our section.
Not efficient?
Yes.
What do you mean by not efficient?
No, it's not for our section.
This is not for your section?
Yes.
How is it possible? Stat 319-02. This is for your section.
It looks different.
We 01. 02 or
No, you're 02. If I'm not an instructor in a course, I cannot create. Someone who's able to access this OneNote, can someone confirm?
Yes, I think this was for our section.
This is for your section because if I'm not the instructor in a section, I cannot create the class notebook. For section 1, 3, 4, or 5, I cannot create. I cannot access class notebook. Muhammad Ali, you get back to me after the class. You share the screen with me, and then we can figure out from where you can access this class notebook. OK?
No, what I mean is that it's look different from yesterday.
Yeah, yesterday I was actually transferring the page from the other notebook to this notebook, and I accidentally deleted. Then I wrote all of it again. Yesterday, I accidentally deleted your notebook by moving from one section to another section. I actually accidentally deleted it, so I had to write everything again. Okay, let me continue with the questions. Now, if you look at everything we have done until this point, whether you are picking a single object or you are picking more than one object, your interest is either directly into the event or in the complement of an event. Until this point, we have not talked about being interested in more than one event. Whether you talk about a single selection or more than one selections, you are interested in what? You are interested in a single event. In every question, you are interested in a single event. Some of the examples are what? In single selection, you said find the probability that the instrument is not half broken. You are interested in C complement here. The instrument was half broken. You are interested in C directly. In this example 4, you said if two instruments are selected with replacement, find the probability both are working. Single event A, you are interested in A, that both of them are working. So all the questions up until this point, if you look at them one by one, for each question, you were either interested directly in an event or you were interested in the complement of an event. That's all the operations we have talked about until this point. So the interest either lies in an event or its complement. Nothing more than this. Diagrammatically, if this is your sample space, and in your sample space, you have an event denoted by this circle A, then the part I have highlighted with the yellow color, that is A. And the part I'm going to highlight with the blue color, that is a complement. Everything outside A this whole thing is a complement. So we have A and a complement. A in the diagram is highlighted by yellow color. A complement is highlighted by blue color. Whether we select a single object or we select more than one objects, we have not talked about more than two events in a single question. Your interest was always in a single event. You pick one object, it is working. You pick two objects, both are working. One is working, second is not working. Anyway, you were talking about one-way organization of the space in a single event. What if you are interested in more than one events? So when you have more than one way categorization of the space, you may be interested in more than one events. And when you have more than one events, you may have two different types of interests. Specifically two events. I'll talk with reference to two events. Let us say A and B. So when you're talking about two events A and B, whether in terms of a single picking or more than one pickings, it doesn't matter. Your interest may lie in joint occurrence of A and B, or your interest may lie in occurrence of either A or B. In set theory, this joint occurrence of A and B is denoted by A intersection B. And this occurrence of either A or B, this is denoted by A union B. This A union B can also be termed as occurrence of at least one of the two events. Either A or B is same as saying occurrence of at least A or B. By at least, you can say either A occurs or B occur or both of them occur. That's equivalent to A union B. Diagrammatically, you have this space, and in the space, you have these two events A and B. These two circles are A and B. So the common area between A and B is the joint occurrence where A and B both are occurring. This whole thing is A. Now you will notice. This yellow part is A. And the blue part is B. And wherever the yellow and the blue part they overlap, that is A intersection B, which actually became green color. So the yellow, green, and blue overall, that is A union B.
Doctor,
Yes.
is it union or intersection? Intersect.
Can you see what I wrote on the screen?
Yeah. Oh, okay.
The yellow, green, and blue all together, all of them, they are union, but only the green color is only intersection.
Understood.
Green is intersection. Muhammad Faris.
Doctor, I cannot say blue A instruction B, right?
B intersection B.
It does not make sense.
B intersection B is B. The
Yes.
common between B and B will be same B. B union B is also B.
So A instruction B, it must all the two circles.
The common area between the two circles.
The common or all of them? A
Intersection is the
B.
common. Intersection is the common. I'm saying this one is intersection. Let me make it clear. This is intersection.
It is not a union.
This is union. Union is like a U.
Yes.
Intersection is like a N.
Union is either one of them, not necessarily.
Union is either one.
Okay.
Yes, 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 Ahmad. Union is either one of them. Intersection is both of them.
Yes, okay. Clear, thank you.
Now, anyone who can tell me what is this yellow area can I represent, excluding the green one, only this yellow area. Can anyone tell me what is this yellow area?
A.
No, excluding the green part. This yellow plus green as a whole is A. Yusuf Zaid.
A union B minus B.
A union B minus B. Yes, it can be written as A union B. Union B minus B. This is one way. Anyone else with a different way? Ali.
Can we say A minus B?
A minus B, no. A minus B will be something else. Abdurrahman.
Complement of B.
Complement of B.
Yes.
Complement of B is everything outside the B. Complement of B includes this area also, everything.
Yes, yes.
Omar.
A intersect complement of B.
A intersection complement of B. Let me see. A intersection. The common area between A and complement. Yes, this is right. This is another way of writing only the yellow part. A intersection B complement. Any other way? Ahmad.
A minus A intersect with B.
This is the simplest one. You can see the whole circle is A. If you subtract the green part, that's actually A minus A intersection B. So all these three things are same. This only yellow pie, I would call it a yellow pie. This yellow pie can be written as A intersection B complement. It can also be written as A minus A intersection B. It can also be written as A union B minus B. Similarly, the blue side, that can be written as A complement intersection B. It can be written as B minus A intersection B. It can be written as A union B minus A on the similar lines. Muhammad Faris.
Dr. A union B, all of the colors together?
Yes, A union B. Let me tell you what is A union B. If this is your sample space, then This whole thing is A union B.
Doctor, in the above statement said either A or B. Is
Either
right?
A or B means this whole thing. Either A or B or both. This is A union B.
Clear now, thank you.
Ahmed Raid.
Doctor, A intersect with not B will include the box too. So it should not be correct.
Which one?
A intersect not B will include the box too.
You mean
The middle one.
you mean A intersection B?
The middle one, A intersect not B.
A intersect not B. This one?
Yes, will include the box too.
No, it will not include the box.
Because not B is everything. Not B, and it will include the box.
Yes, not B will include the box. But
That's
A intersection not B will not include the box. Think about it. I'll give you a half a minute and then I will explain. Think about it again. When you are done, then look at your screen.
Oh, clear. خلاص. No need to.
Do you want me to go or no?
No need. خلاص.
Okay.
Thank you.
Okay, finally, the last thing about these diagrams is something that is called addition theorem. And this addition theorem says that if you are interested in A union B, this probability of A union B can be written as the sum of these three parts, the yellow part, the green part, and the blue part. So that will be A intersection B complement. That was the first part we said, the only yellow part. The middle one is A intersection B. And the last one is A complement intersection B. If you simplify this thing, and mathematically simplifying this thing has nothing to do with your syllabus, only for your interest. If you simplify this thing, you notice that A intersection B complement can also be written as A minus A intersection B. This is another way of writing the yellow part. Look at the last one, that's A minus A intersection B. And the middle one, I'm going to write it as it is. And the last one can be written as B minus A intersection B. So if you look at this thing, there is 1 times A intersection B with a plus sign and 2 times with a minus sign. So you'll come up with this equation that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. This is called addition theorem of probability.
Doctor, it is not 2 multiplied by B A instruction B?
No, not 2. There is this one in the plus, there is one in the minus. These two will cancel out, and
yes.
you'll be left with only 1 times minus. Now, before I move on to a very comprehensive example, I want you to understand some of the basic terminologies that we will use in case of two events. In case of two events, there is a very common terminology used in the question to give some information indirectly. Sometimes we don't tell you an information directly in the question. We tell you the information in terms of terminologies. So one of the terminology that we very frequently use in case of two events is mutually exclusive. When do you say that two events are mutually exclusive? This is a terminology you use when there is no common area between the two events, when the intersection is phi. So the two events are said to be mutually exclusive if they are like what I'm going to draw in the diagram, A and B. No common area, no connection. So these are the conditions, A intersection B when this is equal to phi, or equivalently probability of A intersection B is equal to 0. This implies A and B are mutually exclusive. So sometimes in the question we tell you that A and B are mutually exclusive. We don't tell you that A intersection B is 0. So mutually exclusive means they are 0. Another terminology that we use sometimes is called exhaustive events. Two or more than two events, we call them exhaustive if you join them and you get the space. Let us say the first rectangle is A and the second rectangle is B. If A union B is space, or the probability of A union B is 1, this implies A and B are exhaustive events. And if they don't have the common area also, that means they are mutually exclusive also. In this specific diagram, they are mutually exclusive also because they don't have anything common. They are exhaustive, also mutually exclusive. And finally, there is something called De Morgan's law that you guys are aware of from basic calculus courses. In set theory, this De Morgan's law is very frequently used. This De Morgan's law says that if you are interested in probability, or even not the probability, simple A union B whole complement can be written as A complement intersection B complement. And A intersection B whole complement can be written as A complement union B complement. These two things are called De Morgan's law. So sometimes in question we give you one side and we ask you to find the second side. Sorry. So you can use this De Morgan's law at some occasions. In some situations, this thing is also referred to as De Morgan's law. A intersection B complement, that is A minus A intersection B, and A complement intersection B, B minus A intersection B, which we discussed during the addition theorem. So you need to know these terminologies and these laws. Once you know these terminologies and these laws, now I'm going to directly jump into a question. And here is the question. In this question, let me call it as example 5. In this example 5, it says that I have a batch of students at KFUPM, and this batch has a total 500 students, out of which 150 are from Dammam, 100 are from Riyadh, and 250 are from other cities. So in one way, I'm categorizing my space with respect to the area from where the student comes. So this is first way of categorizing, either from Dammam or from Riyadh or from other cities. Another way of categorizing, now I'm talking about the second way of categorizing, is out of these 500 students, 50 are business students and the remaining 450, they are engineering students. So I'm also categorizing them with respect to the major. So every student, he is categorized with respect to two factors. One, from where he is coming, the area, and secondly, his major. So let me summarize this information and I will show you how some of the missing values in the table can be filled. Now I have a two-way categorization, so I will have a two-way table. This is called a two-way contingency table. In this table, on one side of the table, I will have the city. So I will call it Dammam, Riyadh, and others. Let me name these events as B1, B2, and B3. And out of 500, the overall total of your table will be 500. Out of 500, the question tells me that there are 150 from Dammam, there are 100 from Riyadh, and 250 from other cities. Another way of categorizing we define in the question is according to the major of the student. So that comes on the top. Either you are a business student or you are an engineering student. So the question says, and I'm reading from here, out of these 500 students, 50 are business students, 50 are business students, and 450, remaining 450, they are engineering students. So let me name this event business student as event A. And this one I can name it as another letter, but this basically is A complement. Because I'm assuming the only two categories at KFUPM are business or engineering. So if someone is not in business, obviously he is in engineering. I can use a different notation, no problem, but it's better to give the notation A complement to engineering. Further, I'm going to read the question from here. Further, 15 students are from the mom and, sorry, where is it? 15 business students. So now I'm inside the business category. 15 business students are from the mom. So from the mom, there are 15 business students. This is basically A intersection B1. This cell is A intersection B1. Those students who are also business and also from the mom. And 15 are from Riyadh, same business student. This is A intersection B2. This is it. This is all the information we have. Based on this information, your first job is to fill the table. Raise your hands if you can fill any cell. Muhammad Faris.
Yes, others.
Which one do you want to fill?
I can fill all of them, but others, B3, 20 students are business.
20 students are business. Why you said 20?
Because we have 50 are business, and we have in Dammam and Riyadh, all of them 30.
Okay,
So
and the
50
remaining,
minus-
yes. So we have total 50 business students. 30 of them are from the Dammam and Riyadh, so the remaining 20 are obviously from other cities. Faris, can you also tell me what is the notation for this cell? Like I have A intersection B1, A intersection B2. What will be the name of this cell?
A and instruction B3.
A intersection B3. You can also call it A and B3.
Yeah, A and B3, right.
Ali Al Hassan.
Yes, Doctor. Engineering in Dammam is 135.
135 is engineering and the mom, and what will be the name of this thing?
A complement and B1.
A complement and B1. Amjad.
Yes. Engineering in Riyadh, 85.
85. What is the name of this cell?
We can say not A and
Not
B2.
A and
B2.
B2. Naif.
Others, engineer, it will be 230.
230. Exactly. And what will be the name
Will
of
be
this?
A complement and B3.
A complement and B3. Now, what if I give you two cells in between? I gave you 15, that was A intersection B1, and I gave you 15, that was A intersection B2 in the question. What if I give you only one? If I give you only one, can you fill the table?
Sorry, Doctor, could you repeat the question?
What I'm saying is, if I do not give you this information in the question, the green one, if the question stops at the mom and the green part is not given, can you still fill the table and solve the question?
I don't think so.
We cannot. Naif is absolutely correct. We cannot. We need to have at least 7 informations in the question for a 3x2 table. For a 3x2 table, we need to have not 7, actually 8. We need 8 cells to be there in the question. And what are those 8 cells that we got from the question? Let me tell you. We got this number 150 from the question. We got this 100 from the question. We got this 250 from the question. We got 50 from the question, 450 and this 500. We got 15 and this 15. This all came from the question. So we were able to fill the remaining 4. Similarly, I can give you different cells in the question, not necessarily these ones. I can tell you in the question that there are 15 students of business from the MAM, 135 engineering from the MAM, and I can say the total of the MAM is not known. You can add them together and tell me that the total students from the MAM are 150. So I can hide any of the 4. But I can hide a maximum of 4 cells in this setup, not more than 4. If I hide more than 4, you will not be able to solve the question. Naif, do you have a question? Muhammad Faris.
Yes, doctor. How do you know we need at least 8 cells? Like we said, because we have two measures and 3 cities, and put 2 to the power of 3, or it is another way?
No, there is no way. I just said 8 because the total number is basically 12. So the 4 were missing. It's not a rule. For a different setup, it will be different number.
Yes, clear. Thank you.
So we need at least some information to fill the remaining. That was the point.
Yes.
Okay, now the question, I'll start with the simple questions where I'm going to pick a single student. I'll not talk about picking 2 students. Picking more than 1, we will do it later. So let's say I pick a single student. Find the probability that he is from business major. What will be the probability? So we go step by step. We say let A be the event. We said A is the event. The student is from business. What is N of A? Ali Al Hassan.
Yes, doctor, it is 50 over 500.
Only N of A.
50.
50, yes. What is N of S? The total number of students in the batch.
500.
500. So consequently, what is P of A?
50 over 500.
50 over 500. On a side note, what if I ask you a question that I picked 3 students? What is the probability that 2 of them are business and 1 of them is engineering? Who can solve this question? Raise your hand. Solve it and raise your hand if you have the answer or expression. Not the answer, expression. Let me write the question on the side note. Probability, this is just for your interest, probability of selecting 3 students, and I want 2 business and 1 engineering. I'm not going to do into defining the event, writing the notations, direct answer. Who can give me the answer? Faisal.
Yes, is it 50 combination 2?
50 combination 2.
Times 450 combination 1.
450 combination 1.
Over 500 combination 3.
500, absolutely right. And Muhammad Ahmed, Why do you think Faisal used combinations? Why he did not use permutation? Why he did not use multiplication rule?
Because you didn't mention anything, so we use the default case, which is
because we did not mention anything in the question. Absolutely right. Because we did not mention anything in the question, so we are directly moving towards the default case. We are assuming that we are picking the students without replacement, and the order does not matter. We want 2 business, 1 engineering student in whatever order, we don't care. So that will be the answer. I'm going to erase it because this question does not fit here. I'll talk about this one later. But the point is, you can handle more than 1 pickings now. So let's go quickly step by step. Now I'm not going to write the questions. I'll only use the notation. What is the probability that the student is not from business? Raise your hands. Knife.
It will be 1 minus 50 over 500.
Good. Next question. What is the probability that student belongs to the mom? Faris.
100 over 50. No, 150 and 50 divided by 500.
150 divided by 500. Good. Next question. What is the probability that the student does not belong to Riyadh? Knife. Nawaf, sorry.
400 or 500.
How is it 400 over 500? You can see a table on your screen. From where did you get 400 in the table?
I excluded the Riyadh students.
Okay.
Then added the Dammam and other students.
Good. So it is 1 minus the probability of Riyadh. 1 minus 100 over 500 using the complement rule, or as Nawaf said, you can do it directly by subtracting 500 minus 150 minus 250. What is the probability that if I pick a student, he is from the mom, and he's an engineering? The mom and engineering. Raise your hands. Ahmed.
It's gonna be 135 over 500.
The mom and engineering, yes. Yes. Notationally, it will be n of a complement intersection B1 over n of s. So that will be 135 divided by 500. So let me stop here and I will continue from here in the next class. We had a very nice session today about the intersection and unions. We will continue from here, and in the next class I will try to bring some examples out of this question, some problems where you use both union intersection with more than 1 pickings, like we used for one of the supplementary problems. If you have any question from today's class, you may go ahead. Otherwise, you are free to leave the session now. Yes, Faris, please go ahead.
Yes, doctor. Like these questions, first step, we draw this table, right?
Yes,
And
we call it a contingency table.
yes, this is the first thing.
This is the first step.
Okay. And I have a question in homework that you uploaded. It is all the material was covered or not yet?
No,
For
no,
the-
no, no. We have not covered all the material. For now, you may be able to solve only one or maybe 1.5 question.
Okay. And please, after we cover all the material, tell us because to solve the homework.
Chapter 1, when chapter 2 will be finished, I'll let you know. The homework is covering whole chapter 2.
Chapter 1 and 2, the homework.
1 is not there. That one is nothing.
Nothing. Okay.
1 is like just the definition of statistics.
Yes. So only the chapter 2. Okay.
Only
Thanks.
chapter 2. Yes, Saud Uthman.
Regarding the homework, in the guidelines, it's written that